In this class, we will be discussing about the block diagram of feedback amplifier. The other name of feedback amplifier is amplifier with feedback, or it can also be called as closed loop amplifier, because it forms a closed loop between the input and output of an amplifier using a feedback network. So, the basic blocks of feedback amplifier are signal source, comparator or a mixer network, basic amplifier of forward transfer gain capital A, sampling network at the output side, and from the sampling network it is connected to the feedback network of reverse transmission ratio beta. The output of this feedback network is coming to this comparator. So, there is a closed loop here now, that is why it is known as closed loop amplifier. So, signal source at the input side is a mixer or a comparator network, and at the output side of the amplifier is a sampling network. So, what is this basic amplifier? The basic amplifier can be either a voltage amplifier or a current amplifier or a trans resistance amplifier or a trans conductance amplifier. So, any of these 4 amplifiers are used in this place. If it is a voltage amplifier used as a basic amplifier here, the voltage gain will be AV, voltage gain AV. The basic amplifier is a current amplifier, the gain symbol will be AI. If the basic amplifier used is trans conductance, the gain will be GM. If the basic amplifier is trans resistance amplifier, the gain symbol will be RM. So, again the amplifier of gain A is connected. At the input side of this amplifier, we are connecting a comparator or a mixer network. So, this mixer network can be 2 types of mixing can be done here, either series mixing or shunt mixing, and the sampling network can be voltage sampling or current sampling, and from this sampling network we are taking part of the output and then giving back to the input through a feedback network. This feedback network is a resistive network. So, the feedback voltage is denoted by Vf. This is a resistive network like this. The feedback network is a resistive network. The resistive, this beta is a reverse transmission ratio. Its value lies between 0 to 1, 0 and 1, and the feedback voltage equation Vf is beta is equal to output by input. What is output of this feedback network? Vf, and what is the input here? V naught. Okay. So, what is beta? Beta is equal to output by input. Output is Vf and input is V naught. So, what is the feedback voltage? Vf is equal to beta times of V naught. This is a feedback voltage equation. Okay. And the signal source is connected here, from which the signal will be given to the amplifier. So, the 3 basic along with this amplifier, we are connecting mixer network, sampling network and a feedback network. Sampling network can be voltage or current sampling. If it is voltage sampling, it is known as node sampling. If it is current sampling, it is known as loop sampling, series or shunt mixing. So, we will be seeing there are 2 types of there are 2 ways to sample the output according to the sampling parameter. According to the sampling parameter, if it is voltage or current, depending on that, there are 2 ways to sample the output. One, the output voltage is sampled by connecting the feedback network in shunt across the output. This type of connection is known as voltage or node sampling. If it is connected in series, then we say it is current or loop sampling. Mixer network. What is a mixer network? There are 2 types of mixing. series input connection and shunt input connection. So, we will be seeing in detail about this series and shunt mixing and voltage and current sampling in our next class. So, the basic blocks are signal source, mixer network, basic amplifier of gain A, sampling network, feedback network of ratio beta. So, here the input voltage is Vi of the basic amplifier, the output voltage is V, and the output is taken across the load resistor RL, where you are observing the output voltage V0, where the current I0 is equal to IL, output current is equal to load current, Vi voltage Vi, current II, out voltage V, current I, Vi, V, V0, V0, Vf, the current If is flowing this way. So, this is the basic block diagram of the feedback amplifier. I hope you have understood, and we will be seeing its further details in our next class. Thank you. Good luck, students.